Okay, let's talk about how we might approach a function, a rational function, if we want to sketch its graph. Okay, there again are a lot more details we could go into, but I want to hit the highlights of things we've already covered and some of the new ideas found here in 3.5. Okay, when you are sketching the graph of a function, it is nice to know where that function crosses the x-axis, if it does, where it crosses the y-axis, if it does. Okay, those are things we talked about back in section 2.1. Any place that a function crosses the x-axis or a relation, okay, any shape or size or graph of anything, if it crosses the x-axis, that's the place where y is equal to 0. And if I want to find the y-intercept of anything, not just a straight line, but a circle or a parabola or a sine curve or f of x here that's up on the board, the y-intercepts happen any place that x is 0. And the important thing to keep in mind is when I have a fraction is equal to 0 when the top is equal to 0. Okay, not the bottom, not worried about that at this moment. But if the fraction is equal to 0, that means the top itself has to be 0. And so when I solve for x, I find out x is 5/2. Okay, please be complete when you're giving things like x-intercepts and y-intercepts, when you're writing equations of lines, whether they're horizontal or vertical, that you don't just say things like the x-intercept is 5/2, or the horizontal asymptote is 9, okay, or the vertical asymptote is a number. Okay. Write it as an ordered pair when we're talking about intercepts. Write your equations of lines as proper equations of lines. Plugging in 0 for x gives me 5/3 for y. So my x-intercept is 5/2, 0. The y-intercept is 0, 5/3. Next, we can talk about our asymptotes for the graph. We know that the vertical asymptotes happen any place that the bottom is 0, but the top is not. Okay, so if I plug 3 into the top of this function, it says 6 minus 5, which is 1 and not 0. So that means my vertical asymptote happens at x equals 3. If I'm looking for a horizontal asymptote, then I'm looking at the degree of the top and the degree of the bottom. On the top, I have x to the first. On the bottom, I have x to the first. Since those are the same, then I know my horizontal asymptote is the ratio of the leading coefficients. Okay, the leading coefficient of plain old x is 1. So my horizontal asymptote is the line y equals 1. Now, while I know that x can never be 3, because that makes me divide by 0, okay, there are times and there are situations where we said earlier that a horizontal asymptote can be touched. It can be crossed. So I need to take a moment after I find any horizontal asymptote, and I need to figure out if this function is going to touch or cross it. Meaning, is there a point, a number for x, where I'm going to get y equals 1? Multiply both sides by x minus 3. Sorry, 2x equals 2. And actually this one does. I adjusted my example from what I was going to do initially, so I meant to have one that does not. Okay, although in this one it does. It happens to cross at the point 1, 1. Okay, so I know horizontal asymptotes, I know vertical asymptotes, I know where it crosses the x-axis, and I know where it crosses the y-axis. From here, I'm going to try to create a sketch. Again, sketch does not have to be perfect, but sketch has to go along with all of the things that you told me about. Okay, meaning I can't make it cross the x-axis anywhere other than at 2.5, 0. I can't make it cross the y-axis anywhere other than 0, 5/3. Okay, again, if you're graphing fractions, get them between the right two integers. 5/2 is between 2 and 3. 5/3 is between 1 and 2. Please mark any asymptotes with a dotted line. So x equals 3. Oop, I missed. That's supposed to go through x equals 3 is the vertical asymptote there. And we know the horizontal asymptote is y equals 1. Okay, we did also discover that the graph does cross that asymptote here at this point, at the point 1, 1. Now, the nice thing about asymptotes is they're like magnets for our function. They're magnets for our graph. So as I'm coming from left to right, right here, okay, I know that my graph is going to get closer and closer and closer to that green line. Okay. I also know that with a vertical asymptote, it's never going to touch it and it's never going to go across it. As I go to the left, because that green line is like a magnet, and although I can touch it, it is possible, the only place I do touch it is right there. So I know I'm not ever going to dip back below it as I go to the left, but it is going to be like a magnet. It's going to suck the blue graph toward it and get closer and closer as I go to the left. Okay. So not a beautiful picture, which means I will accept your pictures if they're not beautiful, but they need to have the points plotted in the right places, and you need to have the right general indication of understanding what it does with the asymptotes. Okay. Now notice I have this whole area here on the right side that I have nothing drawn. Okay. Since none of my intercepts, none of my points of intersection, none of that happened over here, that doesn't mean there's no graph over there. It just means I don't have a good place to start. Okay. So what I'll need to do is on my own, pick a number that's bigger than 3, so the right side of my vertical line, and I need to plug it in. So maybe I'm going to say I need to find f of 4, and I'll see what comes out. So f of 4 is 8 minus 5 on top, 4 minus 1 on the bottom. F of 4 is equal to 3. Okay, or that's code for saying it goes through the point 4, 3. When I put the dot up there, that dot is really all I need to get a sketch for the rest of the graph. Because I know as I'm moving to the left, I know I have to go up. I'm going to get closer to this line but never cross it. I also know that the only time I crossed the line, the horizontal asymptote, was back here at 1, 1, so I'm not ever going to touch or cross that one again. So that means I can't go this way with my graph. That wouldn't be right. Okay, so it leaves me with no choice but to say that side goes up and this side goes down. Again, it's going to approach that green line as we go through. Okay, if you wanted to go to Desmos or somewhere and type in that function, look at a picture of it, it should look similar. Again, a little smoother than my left side, but still very similar to this. Okay, I'm going to make one more of these, but I'm going to put it in a separate video.